In this video series, we're going to be learning about writing your own functions. By the end of this series, you should know how to import a function written in an external file, know the syntax for creating your own named function, know where to include the function in your Python code, and we'll review the syntax for making function calls in Python. Before we start writing our own functions, let's review why functions are useful in programs in general. In the last module, we learned that a function is a bundle of executable Python instructions that have a name attached to them. So essentially, it's a sequence of Python instructions that somebody's written, and those instructions perform some useful activity. And to make those individual statements reusable, the programmer has attached a name to that sequence of statements. And that allows themselves and other programmers to utilize that sequence of instructions by just using the name of the group. Functions are useful because they help to organize programs, kind of like paragraphs or sections in a paper. So rather than just having maybe 100 or 1,000 lines of code in a single file where it's hard to piece together which items are related, if you organize your code into functions, it's kind of like sections in a research paper where you have a bundle of instructions that perform one activity and then a separate bundle that perform another activity. It makes it easier to visually process the code that's within that file. Another important benefit of functions is that they facilitate abstraction and the reuse of code. Once a function's written, you can reuse it over and over again without rewriting all of the algorithm steps, and that helps to reduce programming errors. In the last module, we saw some built-in functions, things like the print function, the input function, the length function. All of those are things that are part of the Python standard library. The Python standard library is automatically accessible from every Python program. You don't have to do something special to gain access to the standard library. In order to use a function within the standard library, you need to know what kind of information needs to go into that function. That's called the arguments. And you need to know whether that particular function produces a result that will be returned as a value from the function. And that's the output from the function, the information that's communicated back. You may have seen some examples where we use functions that aren't defined in standard libraries. For example, perhaps you've done one of the coding challenges where you used the random number generator library. That's a non-standard Python library. A non-standard library means that it's code that's bundled together into functions, but it's not used so frequently that it gets imported into every single Python program. Instead, Python relies on the programmer to pull in that set of functions anytime they're going to be performing those types of activities in their program. So if you want to use information in a non-standard library, you have to import the code into your program. And that just provides your code with access to the functions that are defined in that non-standard library. Last week, we saw how to use a non-standard library using the random library. And we used two specific functions that are part of the random library. We used the seed function and also the randint function. We know the seed function, we used that to initialize a random number generator so that we could get reliable data over and over again. The program would have the same behavior when we ran it. And that was useful for testing. Then when we wanted to fully randomize the behavior of the program, we took out the seed function so that it would be more unpredictable. The randint function was the powerhouse of our programs in the last module. The randint function allows us to generate a pseudo-random value, something that appears random to us. In order to use both of these pre-written functions, we had to import them into our code. And the syntax in general for importing a library looks like this. You say from, and then fill in the library name, and then the reserved word import, and then you list all the functions that you want to include. If you have multiple functions, you separate them by commas. So for example, if we wanted to use both the seed function and the randint function in the random library, we'd say from random, because random's the name of the library, and then we'd say import, and then we'd specify the function names that we want to import. In this case, those are seed and randint. Let's look at another example. Suppose that we wanted to use these three functions, factorial, floor, and square root, and suppose that these functions are part of a non-standard Python library called math. How would you specify that you wanted to have access to those functions in your code? You'd start with the reserved word from, and then you'd include the name of the Python library, which is math in this case, because it told us that's the name of the library. And then we'd say import, and then we'd list all of the function names that we want to import. In this case, there's 3 of them. We want to import factorial, floor, and square root. And we just separate each of those by a comma. And that single line would give us access to all of those functions that are part of the Python library. And that single statement would give us access to all of those functions that are part of the non-standard Python library called math. Sometimes we might want to utilize a function that somebody else might have written, but maybe it's not important enough or common enough to be part of the Python library, the standard library, or a non-standard library like random. For example, suppose your friendly 110 instructor wrote a function to do something really useful and you wanted to use that function in your own Python program. Code's probably not going to be used frequently enough to be included in the Python standard library that's available worldwide, and probably not even going to be used frequently enough to be included in a non-standard Python library, but you might still find it very, very convenient as you're working on your Computer Science 110 assignments. So suppose that Dr. Annawalt wrote an awesome function to test the validity of a credit card type. You might be working on a programming problem where you're validating a credit card or some other kind of number. And if your instructor had written a function that provided part of the tests that you need to perform on that number, wouldn't you want to use their function instead of reinventing the wheel and writing your own version of the code? Sure, that would save you a lot of time. You wouldn't have to test it because you would have confidence in your instructor's solution. So it would be a good deal. You have the ability to use a function that's written in a local file. And in order to do that, you just need to do the following. First thing that's important is you need to have access to the file where the function's defined. So for example, if you're using a function that's not part of the standard library or a non-standard Python library and you want to gain access to it, you have to have the file that includes that function's code somewhere on your computer. So your instructor would have to give you access to that file and you'd have to download it and store it in your Python directory. Then after you do that, you'd use the import reserved word to import the function into your Python program. And then finally, you'd have to make a function call to that function that is provided in the file using the appropriate arguments, and you'd have to store the return value and do all the normal things that you do when you call a function. Let's look at the syntax for importing a function that's stored in a separate file. So in order to do that, you say from and then a file name, where the file name represents the actual file where that particular function is stored. Then you say import and then list all the functions that you want to include. Suppose Dr. Annawalt wrote a function and stored it in a file called creditcardlibrary.py. And suppose her function is named isCardTypeValid. And she tells you it takes one parameter, it's the card type that should be tested, and that this function returns a true or false value to indicate that the card type is or isn't valid. So let's think about what would the Python code look like to import this function into your own program. So again, assume that you've downloaded Dr. Annawalt's file creditcardlibrary.py. Then in your own Python file, you'd say from, and then the name of her file, credit card library. And you don't include the .py there. Python automatically knows to look for a file called creditcardlibrary.py, and you shouldn't put that extension as part of the file name. And then you want to include the reserved word import, and then the name of the function. We're told the name of the function is cardTypeValid. And you can see that looks really similar to importing a function that's in a non-standard Python library. It's actually exactly the same. The only thing that's new and different is that the from piece is the name of a file rather than the name of a library, because a library really is just a file. It's just a file that's included in the Python installation. Now, suppose that we have a credit card stored in a variable called card type. How would we call the isCardTypeValid function using card type as an input to that function? So again, what we're saying is We have this black box. It's called is card type valid, and we want to pass in card type as the input. And we know that we're going to get a true or false value back as the output. It tells us that's the return type for this function. What would that function call look like? So we'd have something like result equals is card type valid, and then we need to pass in the one argument that's expected. It's the card type. So now let's put all those pieces together into an example program. Suppose that we were writing a program and we want to allow the user to enter a credit card type, and then we want to utilize Dr. Annawalt's solution in her is card type valid function to print out a message saying that the card type is or isn't valid. In our program, at the very top, we'd import the is card type valid function from the credit card type library. And we want to import our function. It's called is card type valid. So it's the first line that we're adding there. Then we'd have a line that asks the user to enter input. They'd enter their credit card type. And in our world, credit card types are things like MasterCard, Visa, American Express, all the common credit card types. So you enter one of those values or something else as a string. And then we want to make a function call to our is card type valid function to figure out whether the card is or isn't one of those valid credit card types. So I'm going to say result equals. And then the name of my function is card type valid. And I want to call it using my card type, the user data, as the argument. And then the rest of my program is already good. We check to see if the result that's returned from the is card type valid function is true. If it is, we print out a positive message saying the card type's valid. Otherwise, we're going to print a message saying the card type's invalid. I brought up an example program for you right here. So I have my function declared in another file. And if I'm just using Dr. Annawalt's solution, I don't really care what's in that other file. I just need to know all the details about the is card type valid solution. I need to know where is that located, what's the file name, and I have to have that file downloaded on my computer. I need to know what's the name of the function. I need to know what kind of arguments it takes and what the return value is. And we've received the answers to all of that information from Dr. Annawalt. So we are all set to go. In our program, we're importing from the credit card library. That's the name of the file where her code is stored. I want to import is card type valid. It's the name of her function. Then in my own program, I can ask for input and I can call her function to execute this useful validity check on the credit card type. And then based on the information I get back, I can print out a positive message or an error message. Let's try it out just to show that it works. So if I run my Python program here, I can enter a credit card type. Let's say I have a Visa card and it tells us your Visa is valid. Let's say that we enter in something like MasterCard. Again, it's going to tell us MasterCard is valid. Let's try it with something that's not a real card type. When we type in something that's not one of the valid credit card types, it prints out error unknown card type and then the garbage. That's the error message that we told it to print. And notice that nowhere in our code did we have anything that checked to see if the data that was entered was MasterCard or Visa or something else. All of the algorithm for validating that card type is hidden in Dr. Annawalt's is card type valid function. And that's that black box abstraction idea where we don't need to know what's inside there. We don't need to know what that code looks like. We just need to know how to call it, and then we can successfully utilize it in our own program.